force notes. This is momentum. All right, so go to the flap that has momentum in there, and let's go ahead and do this real quick. What you need to know about momentum is that it is mass in motion. So this is kind of like the inertia of motion. Okay, so think about it like that, the inertia of motion. Something in motion is going to want to stay that way. It's harder to move something that has more mass because more mass equals more inertia, right? Objects at rest will have zero momentum, but they will have all of their inertia, right? They will have no momentum because the equation for momentum is mass times velocity. So if you're at rest, you know that that means velocity equals 0, right? So you'd be plugging in a 0 to m times v, and that comes out to a big fat 0, right? Okay. The definition is it is the mass, which is m, and the velocity, v, of an object. It is related to how much force is needed to an object's to change an object's motion. So it's related to the amount of force needed to change an object's motion. All right, how much force is needed to change an object's motion. And what's the unit for force? The Newton, right? Mass, kilogram, velocity, meters per second, right? All right, the unit for momentum is, well, if you look at mass times velocity here, mass is the kilogram, and meters per second is velocity, so you just combine the two. So the unit for momentum is kilogram meters per second. Okay, momentum, this is the law of conservation of momentum. Momentum cannot be created or destroyed. It is only transferred. All right, put an N in there, sorry about that. It can only be transferred. It can only be transferred from one object to another. Momentum is transferred in all collisions. That means like bumps. They bump into each other. Here's the equation right here. P is momentum, not M, but P. This symbol right here, make sure you star that. P is the symbol for momentum. Okay, P is the symbol for momentum. It comes from a Greek word which means to fly or to be moved. It's protishtai. Okay. So that's momentum equals mass times velocity. And the way you can rearrange this is in a triangle here, P, M, V. So if you are missing velocity, you can just divide momentum by mass to get velocity. If you're missing mass, you could divide P by V to get M. And if you're missing P, you just multiply these right here, right? And you see this is like a big division bar, right? Okay, so you could use this triangle, but let's go ahead and do the algebra here. So if I divide by V on both sides, look what you end up getting. You get P over V equals M. Okay, so let me go ahead and erase that. So M is equal to P divided by V, and then of course you could divide it the other way as well. V is equal to P over M, so momentum over that. Okay, look at this video and let's kind of see how this works real quick. So the conservation momentum here, so look at that, boom. This guy's waiting here, he's got, how much momentum does he have right now? Well, he's got a mass, right? But he doesn't have any velocity, so he has zero momentum. This guy, on the other hand, has mass and velocity, so he has momentum. So look what's going to happen. As he runs into this guy here, look, he pretty much comes to a stop and transfers all of his momentum over here. See? Cool, right? Okay, so let's see this guy right here. All right. How much momentum? Zero, right? Here he comes. Boom. And it kind of brings him to a stop, if you notice that, right? Okay, so let's see some of these. Here we go. Check this out. So now they are both going to run towards each other. So look, if this guy's running in the positive direction, she's running in the negative direction. So her velocity is negative, his velocity is positive. So what's going to happen to their momentum? Well, negative momentum, positive momentum. And look what's going to happen. Boom. She got thrown away because his momentum was much greater. The larger mass is usually not going to recoil back. Okay, that's very, very important. Okay, so that's just some basics in that, and I hope that helps with your understanding momentum. So look here, smaller m, larger v, larger m, smaller v, right? So these have to balance out, right? Okay, good luck.